So today, we are going to talk about the first unit in classical mechanics, which is describing motion, kinematics in one dimension. By the way, I am Jelina Macaraeg and I'm from the section of PSED 1F. So, I know that some of you are already familiar with this topic because in this unit, we are going to talk about the distance and displacement, average and instantaneous velocity, constant speed and constant velocity, acceleration, and especially the motion. So, let us first know what is the difference between distance and displacement. So, when we say distance, it is a scalar quantity, which means it has only magnitude but doesn't have a direction, while the displacement is a vector because it both have magnitude and direction, and it is also the differences between two positions. Generally, when we give directions, we use the geographical directions such as the north, east, south, and west. Let's proceed to average and instantaneous velocity. So, when we talk about average and instantaneous velocity, we need to define first what is velocity and speed. So, velocity refers to both the speed and the direction of motion of an object. Thus, velocity is also a vector quantity because displacement covered by a body per unit of time, while the speed is the rate of movement irrespective of direction. It is equal to distance traveled divided by travel time, or the rate change of distance with respect of time. In a mathematical equation, S is equals to d over t, which means d is the distance and t is the time. So, what is instantaneous speed? When we say instantaneous speed, this is the speed that we read on the speedometer. For example, if the bus speedometer indicated 60 km per hour, it means that at the instant you glance at the speedometer, the bus was running at 60 km per hour. The 60 km per hour is the instantaneous speed of the bus. So what is instantaneous velocity? When we say instantaneous velocity, this is the velocity at a given instant. Constant speed and constant velocity, how they are interrelated or connected to each other. So, to have a constant velocity, an object must have a constant speed in a constant direction. Constant direction constrains the object to motion in a straight path. Thus, a constant velocity means motion in a straight line at a constant speed. So, if the motion didn't go straight to the line or it goes to another direction, that is not a constant velocity. Let's proceed to acceleration. We all know that in physics, acceleration is the rate of change of velocity over time. For example, when you press down on the gas pedal in a car, the car surges forward going faster and faster. This change in velocity is called the acceleration. So, what is motion? In physics, motion is the change with time of the position or orientation of a body. Motion along a line or a curve is called translation. Motion that changes the orientation of a body is called rotation. In both cases, all points in the body have the same velocity, directed with the speed, and the same acceleration. The most general kind of motion combines both translation and rotation, and that is the motion in physics. So, let us have a practice problem. So, an airplane accelerates down a runway at 3.20 meters per second squared for 32.8 seconds until it finally leaps off the ground. Determine the distance traveled before takeoff. So, I will show the solution and I will explain the step-by-step process on how did I come up with the answer. So, the given are 3.2 meter per second squared, which is the acceleration, and the time 32.8 seconds, and the initial velocity will be 0. So we're going to find the distance. So in getting the distance, we are going to multiply the initial velocity to time plus 0.5 and multiply by the acceleration, and we're going to square the time. So substitute the given equation. So 0 meter per second, that is the initial velocity, multiply by 32.8 seconds, which is the time, plus the 0.5 multiply by 3.20 meter per second squared, that is the acceleration. And we're going to square that acceleration. So in calculating those values, the calculated distance is 1,720 meters. So the distance traveled before the takeoff is 1,720 meters. So that's all for today. Hope that you all learned something from me. And happy learning, keep safe, and God bless.